Hello everyone, this is Team 404 Found and this is our project floatChat AI. So the problem is ocean data is very vast, heterogeneous and it is distributed in unorganized manner via NetCDF file. So the problem with NetCDF file is NetCDF file data is very much unorganized and an LLM model cannot pass this data, due to which it becomes very difficult for researchers and non-domain experts to research based upon ocean data and extract this data. So, a potential solution to this problem could be to develop a relational database and a vector database so that we can put data and retrieve data efficiently, to set up an RAG pipeline for better retrieval and generation, and to improve the context that is given to an LLM model for better and correct response. And third, to use data visualization tools in the front end for better analysis and visualization of the data. So, how did we implemented this? So first we have extracted all the data from Argo's official FTP server. Then we have converted this, extracted the data from the netcdf file and converted this data into JSON format. And then this data has been put into Postgres database. Now this raw JSON data is then converted into paragraph format in using an LLM model Llama, and these paragraphs are then chunked and embedded using an embedding models, and then this embeddings has been put into an ChromaDB for semantic search purposes. Now whenever a request is made by a server to this API endpoint for AI analysis, it first fetches the similar metadata from the ChromaDB based on the prompt, and then it uses this metadata as a primary key to fetch all the other data from the PostgreSQL database. This entire data as a reference is then given to the LLM model for better understanding and summarization, and then the response is passed back to the server. This was our main RAG pipeline. Now, other API endpoints which we have been made are used for the front-end data visualization. First, we can get all the WMO, all the profilers which are present in the database. Second, we can fetch all the cycle data based on a particular profiler WMO number. Third, we can fetch all the metadata of a particular profiler based on the WMO number. So let us look this in action. So first, this is the chat interface. Here I can write prompts like salinity data of Atlantic Ocean in June 2025. It will first fetch all the metadata from ChromaDB based on this prompt. Then, based on the metadata as a primary key, it will fetch all other data from the Postgres database, and analyzing all the data, it then generates the response. So, this is the response. In June 2025, the 11 June data point is taken. This is the latitude, longitude, the average salinity, and all other data are given. So these are the data points which has been taken. First, it's a May data point. Second, it's a June 11 data point, and third, it's an April 6 data point. These all other nearby data points are also compared so that a comprehensive response can be generated. Similarly, I can ask him other questions such as uh, average temperature of Atlantic Ocean near equator. So this is a location based question. I can also give him location based question. It can fetch the nearest location which is near equator, analyze the data and give a summarized response. So it will again fetch the data from the database and analyze it and give us the perfect response. So here is the response. So average temperature of Atlantic Ocean near equator demonstrate it's ranging from 7.6 degree to 7.9 degree. Okay, so here are all the data points. These data points has been piled up. So more you prompt, the better data response you get. So another, this is the front end dashboard. So here all the profiler, this yellow dots has been shown by all the profiler data, the API endpoint which has been made. Now I can click here at a particular WMO number. This is all the metadata which are related to this WMO. Now here all the individual cycle data, the number of cycle it has, these are all the individual cycle data, that data of cycle 5, data of cycle 8. And these are charts. There are total 80 cycles. Each cycle data has been given here. Now in charts, there are temperature versus salinity chart, temperature trend chart, how the temperature has been based on each cycle. There is salinity based on each cycle, and there are profile data which compares temperature, salinity, and pressure. These are some other charts. We can give one short trajectory which shows the entire trajectory of the float that it's deployed on here and how the floats is going. Now, if we click on a particular node, we can also see the node data also. This has been fetched using an API. So each node data can also be shown. Also, we can use some filters here based on the transmission system, date, ocean type, and the data acquisition center which it has been stored. And we can also compare the floats. We can select here one, two, four, any number of floats, and we can compare all the floats. So this is an holistic approach for the entire problem. We have set up a rack pipeline for better retrieval and generation of data, so that you can set up a conversational AI to better research on the data, and we have created a front-end dashboard for data visualization, charts, and comparing data based on the floats number and also using temperature, salinity, and pressure. So that's all about our project. Thank you. Signing off.